Welcome back, 9th standard. In the last video, we discussed how to find out the surface area of a cuboid and a cube. We also learned how the formula has been established. Now we'll be applying those formulae in order to do the questions from your first exercise of chapter number 13. Exercise 13.1 on page number 213 of your NCERT textbook. Let's take a look at the questions. So the first question that we have is a plastic box 1.5 meters long, 1.25 meters wide and 65 centimeters deep is to be made if it is opened at the top. It is opened at the top. Ignoring the thickness of the plastic sheet, determine the area of the sheet required to make the box and the cost of the sheet if a sheet measuring a meter square costs 20 rupees. Since the box is open at the top, the sheet will be used on the sides and on the base. So in order to find out the area of sheet, that is what we need. The area of the 4 lateral faces and the area of the base. Now this can be calculated in 2 ways. Question number 1, you've been given the length, breadth and height for the box. The length is 1.5 meters, the breadth is 1.25 meters and the height is 65 centimeters. Before we proceed, we first notice that the units are different. These two are in meters and the height is in centimeters. So we will convert. This can be converted into meters by dividing it by 100. 1 centimeter equals to 1 by 100th meter. Now why I have preferred to convert in meters, because later in the question, in second part, you can see that the cost has been given for 1 meter square. The cost will depend on meter square area. So I need to find out the area in terms of meter square. That's why I need the values in meters. Length and breadth were already in meters. I've converted height also into meters. Now to find out the area of the sheet that I need, I can do it in 2 ways. Area of the sheet needed can be calculated in 2 ways. Since the box is open on top, I don't want the area of the top face. So what I can do is I can take the total surface area, which will be the area of all 6 faces. From this area, I'll be subtracting the area of the top. So this means for the total surface area, the formula is 2 times LB plus BH plus HL. From this, the area of the top, which is given by the product of L and B, this will be subtracted. So I will be using the values in this expression, solve it. I'll solve the product LB using the values from here, and then I'll subtract the 2 answers in order to obtain the area of the sheet. Now this can also be calculated as taking the lateral surface area, the area of the 4 side walls, plus the area of base. Either from the total, subtract the top, or take the area of the side faces, the lateral surface area, and add the area of base to it. Now the lateral surface area is given by 2 times L plus B into H. The base area is given by LB, same as the top area. So you can add this. So you can find out the area using this expression, or you can find the area using this expression. Both answers would be same, and the answer will tell you how much sheet is needed. And then once you have your answer, you can find out the cost of the sheet, which has been given as 20 rupees for 1 meter square. So 20 rupees per meter square. So the cost of sheet needed in this case will be equal to the area of sheet. This actually is the answer from part number 1. This will be multiplied by 20. So this is how you will do first question. Moving on, question number 2. Question number 2, it's a similar question. The length, breadth and height of a room are 5 meters, 4 meters, 3 meters respectively. find the cost of whitewashing the walls of the room and the ceiling at the rate of 7 rupees 50 paise per meter square. Again, we have to find out the cost for the whitewashing. The whitewashing is to be done on the walls and the ceiling. The floor will not be whitewashed. To find out the cost, we first of all will find out the area to be whitewashed. The area to be whitewashed will be the area of the four walls and the area of the ceiling. Now this again can be done exactly the same way the way we did the previous question. The area to be whitewashed can be calculated using two ways. So area to be whitewashed, this can be calculated using two ways. You could take the total surface area, which means the area of all the 6 faces of the room, 4 walls, the ceiling, the floor. But the floor is not to be whitewashed, so we need to subtract the area of floor or the base. So this will be 2 times LB plus BH plus HL minus the area of the base is given by LB. Or you could use the area of the 4 walls plus the area of the ceiling. So area of the 4 walls is the lateral surface area, and the area of ceiling, which is the area of top. So just for reference, if you want, you can remember it for yourself that the lateral surface area is the area of 4 walls and area of top is the area of ceiling. Let's write down the formula that we use for these. The lateral surface area is given by 2 times L plus B into H plus the area of top, which is given by LB. So you can either use this expression, you will find out the area to be whitewashed, or you can use this expression. This will also give you the same value, the area to be whitewashed. And once you have the area to be whitewashed, you can find out the cost of whitewashing. The cost of whitewashing per meter square is given as 7 rupees and 50 paise. So the cost of whitewashing 4 walls and ceiling will be equal to the area obtained from here multiplied with 7 rupees 50 paise. So this is how you will do question number 2. Now let's take a look at the next question, question number 3. Question number 3. The floor of a rectangular hall has perimeter 250 meters. The cost of painting the 4 walls at the rate of 10 rupees per meter square is 15,000. So what you've been given is the perimeter of the floor. You've not been given the dimensions directly. You have directly been given the perimeter of the floor. Now if you recall from the last video, to obtain the perimeter of base, we will be using the dimensions of the base, and the dimensions of the base are represented by L and B. So if this represents the hall, so this is the floor, this is L, this is B. So the perimeter will be 2 times L plus B. So this has been given as 250 meters. Further, the cost of painting the 4 walls. 4 wall means the lateral surface area, if painted, costs 15,000 rupees in total, and the cost per unit is 10 rupees. For 1 meter square, the cost is 10 rupees, and the total cost of painting the 4 walls is 15,000 rupees. You have to find out the height of the hall. So what we are going to do is, we will let the height of the hall as x, or you can simply represent it with h. we will proceed the way we would normally do in order to find out the cost of painting the 4 walls. Now you've done that previously. In previous question you found the cost of whitewashing the walls and the ceiling. In this case, let us find out the cost of painting the 4 walls. Whatever the cost we obtain, it will be equal to 15,000. So we will be making an equation and solve that equation in order to find out the height of the hall. So let's see what we have. Let height of hall be h. Now the units are meters. The area which has been painted, area painted is the 4 walls. So that means the lateral surface area has been painted. This will be given by 2 into L plus B multiplied with H. This is something which is given to me, that the perimeter of the base is 250 meters. So I'll be using it here now. So 2 times L plus B, the value is 250 multiplied with H. This is the lateral surface area. The units will be meter square. Now, if this is the area, 250 H meter square, what will be the cost? Ignoring that our answer contains a variable, let us imagine that this is just a number. So we have obtained how much area is to be painted. Now we want to find out the cost. What we've been given is the cost of painting 1 meter square is 20 rupees. Sorry, it's 10 rupees. This is what's given. And if we had to find out the cost of painting this much of area, the cost of painting 250 H meter square, we have the cost for 1 meter square. To find out the cost for 250 H meter square, from 1 to many we multiply. So this means the area for which we want to find out the cost will be multiplied with 10. So this is what will be the cost. This is the cost. But according to question, the cost is 15,000 rupees. So this is the cost according to us, and this is the cost according to the question. So the two answers should be equal. There should be 2,500 H equals to 15,000. So from here you can find out H. Solve it. The value of H will be in meters. Now let us do the next question. Question number 4. A paint in a container is sufficient to paint an area equals to 9.375 meter square. How many bricks of dimensions as given can be painted out of this container? So there is a container which contains some paint. That paint can be used to paint an area equals to 9.375 meter square. So the capacity of the container is to paint an area or equals to 9.375 meter square. There are bricks of given dimensions 22.5 centimeters by 10 centimeters by 7.5 centimeters. When the dimensions are given in this product form, by default the first value represents length, the second value represents the breadth, and the third value represents the height. So there are some bricks to be painted whose size is given to us. We have to find out that if we use the container which can paint this much area, if we use that container, how many bricks would be painted? So for this we are going to apply the concept of, you could say, unitary method or direct inverse proportions, if you can recall. So first of all, we will find out what is the area of one brick. So area to be painted for one brick. Then the area that can be painted out of the whole container will be divided by the area of one brick. And by area, I mean the total surface area, because the brick is to be painted all over. So I will be calculating the total surface area. So the area which can be painted out of the whole container, total area, divided by the total surface area for one brick, that will give you the number of bricks. Now this question is kind of similar to the questions you did in your junior classes, where you have to find out the number of tiles. So you need to find out the number of tiles if you are aware how much area is to be tiled, the area of the surface on which the tiles are to be fixed, and you are aware of the area of one tile. Then you can find out the number of tiles by dividing the two. The total area which needs to be covered with tiles over the area of one tile. Same concept will be used here. So just for your reference, if you want, you can recall that number of tiles is given by the total area to be tiled over area of one tile. So this kind of concept will be used here to find out the number of bricks that can be painted out of the container. So total area that can be painted out of the whole container divided by the total surface area of one brick. So this is the concept we'll be using here. So the first thing that you will do here in question number 4th is you will first of all find out the total surface area of one brick. And the shape of the brick is cuboidal. So the total surface area will be given using this expression, 2 times LB plus BH plus HL. And the area, this is given, area. So this is actually step number 1, where you find out the total surface area of one brick. Then step number 2, what is given? We've been given that the area that can be painted out of whole container, if we use the complete container, how much area can be painted? So this is given as. And then finally step number 3, where we find out the number of bricks that can be painted out of the container. So this will be area which can be painted in all, the total area, which is this, over the total surface area of one brick. Now while you do this question, there will be one catch. The dimensions of the brick are given in centimeters. So the area of brick will come out to be in centimeter square. The total area which can be painted out of the container is given in meter square. So when you divide this, you will have this catch here. The units don't match. So you can either convert these values here, or you can convert the dimensions before you calculate your area. You could convert the quantities in the beginning, convert your values from centimeters into meters, then the answer will be in meter square, and then you can directly use those values here. Answer obtained in meter square and the value given in meter square, then you can divide the two. But if you solve in centimeters, after calculation of your answer, you can convert afterwards. So to convert meter square or centimeter square into the other units, what you can do is, if you're converting meters to centimeters, this is the relation that you use. 1 meter equals to 100 centimeters. If you want to convert the units of area, these are the units of length. For conversion, you use this. If you want to convert meters into centimeters, you multiply with 100. If you want to convert centimeters into meters, you divide by 100. Now these are the units of length. If you want to convert the units of area, which are in square centimeter or square meters, that's square units, what we do is, 1 meter square is given by 100 into 100 centimeter square. So that means 1 meter square equals to 10,000 centimeter square. What I have done is I have squared both sides, the square of this side and the square of this side. So 1 meter square equals to 10,000 centimeter square. So if you want to convert a meter square to centimeter square, you will multiply with 10,000, and if you want to convert centimeter square into meter square, then you would divide by 10,000. So you could either use this. Whichever way suits you, you can find the answer accordingly. Alright, class 9th. Continuing further with the exercise 13.1. Question number 5. Now this one is an easy one. It is a direct question. There is a cubical box with edge 10 centimeters and another cuboidal box which is 12.5 centimeters long, 10 centimeters wide and 8 centimeters high. Which box has the greater lateral surface area and by how much? Then second part, which box has the smaller total surface area and by how much? So this question is very simple. For the first part, you will calculate the lateral surface area for the cubical box and the cuboidal box, compare the two and see which has the greater lateral surface area. For the second part, you will find out the total surface area for both the boxes, the cubical one and the cuboidal one, and compare the two to find out which box has the smaller total surface area and by how much. For the how much part, you subtract the two values, bigger minus the smaller one. So I'll just quickly write down the clues for this. You could do it side by side. For the cubical box, the edge is given as 10 centimeters. So you could find out the lateral surface area, which will be 4 times side square, which is a square. So this will be 4 into 10 square. You can solve it. And for the cuboidal box, you've been given the length as 12.5 centimeters, the breadth as 10 centimeters, and the height as 8 centimeters. So you find out the lateral surface area for the same. For the cuboidal box, the lateral surface area will be given by 2 times L plus B into H. So 2 in the brackets, you will have 12.5 plus 10 multiplied by 8. So this will also give you the answer in centimeter square, and then you can compare and then answer which shape has greater lateral surface area, and then you find out the difference. So these will be the 3 steps: finding the areas, comparing them to see which has the greater lateral surface area, and then by how much will be given by the difference. So this will be the first part. Now the second part. For the second part, you need to find out the total surface area for the two boxes. For cubical box, the total surface area will be given by 6a square, which is 6 into 10 square. The answer will be in centimeter square. For the cuboidal box, the total surface area will be given by the formula 2 times LB plus BH plus HL. Find the values by substituting LB and H here. The answer will be in centimeter square. After you have the total surface area for both the boxes, you compare the two. After comparing, you need to give the answer which box has smaller total surface area. And then finally by how much. For that, you need to find out the difference. So these will be the 3 steps for the second part. Find the total surface area for both the boxes, compare to find out which has the smaller total surface area, and then find out the difference. Now let's take a look at question number 6. A small indoor greenhouse, which is called a herbarium, is made entirely of glass panes, including the base, held together with tape. Now you could imagine an aquarium which is made out of glass panes. The glass is used on all the four faces and on the base. The top is open in case of an aquarium, but for a herbarium, all six faces are made of glass, and two glass panes together along the edges are fixed using tape. The dimensions are given, the length, breadth, and the height is given. You have to find out first the area of the glass. Since the glass is used to make all six faces, the area of the glass will be given by the total surface area of the herbarium. In the second part, you have to find out how much tape is needed for all the 12 edges, since all the glass panes have been held together with tape. So along the lengths, breadths, and heights, they have used tape. So keeping that in mind, let us see what we'll do. So you've been given the length, breadth, and the height. The length is 30, breadth is 25, and the height is also 25. The dimensions are given in centimeters. For the first part, where you have to find out the area of glass, you will find out the total surface area, because the glass has been used on all six faces. Since the glass has been used on all six faces, finding the total surface area using the expression 2 times LB plus BH plus HL. So this will give you the answer in centimeter square using these values over here. In the second part, you have to find out the tape needed. So the length of the tape needed to hold together the glass panes. So if this is your herbarium, the tape has been used along the lengths, breadths, and the heights. So all the horizontal line segments, they represent the lengths. So the tape has been used over here along the horizontal line segments. Then the oblique or the slanting line segments represent the breadth. So the tape has been used for these four slanting line segments. And the vertical edges, these are the vertical edges, these represent the height. So four vertical line segments means four heights. These have also been held together using tape. So the tape needed will be given by 4 times each of these edges. This is 4 times L plus B plus H. This will give you the length of the tape needed in centimeters.